Okay, so today we're talking about the first day of review for the final, and I'm going to be going through some topics. This will certainly not be everything you need for the final, not even close. We've only got 3 days to prepare for the final, and the final, it covers the whole semester. All right, this one you break up into two parts, and you'd have 2x and 2x, because that makes 4x squared, right? And then what makes the 9? The 3 and the 3, good. And then a plus and a minus. That way you know you've done the outside and the inside and they canceled, and that's why there's no middle term. The first's made 4x squared, the last's made 9. It's perfect. Raise your hand if you had that one right. That's most of you. Good. Moving on. Factor this one. It's definitely hard, but it's doable. I will get you started just to make it less crazy. 7x and 2x. So you should be thinking of a number that would multiply to 5. Well, that's pretty easy. 1 times 5. Then it just boils down to, is it -5 and +1, or +1 and -5, and where should I put it? And all you can do is guess and check. Just try it. What if I try it here? Outside and inside. The outside makes -8, inside makes +10. That's not even close to 33. How can I get my numbers to be bigger? Switch them. I put the 5 on the other side, then the 5 will be times by the 7. That would make a lot more sense. Now, the -5 times 7 would be -35. Now we're talking, because that's really close to 33. And then this +2 cuts it down just enough to work. Yes, there it is. Okay, so you got to be able to factor. Sometimes it's factoring because then you need to cancel things, like maybe this would have been a big problem when there was a 7x plus 1 on the bottom, and then this would cancel this. And okay, so, but you need to factor for a lot of different reasons. All right, next page. You remember how to factor this kind, where you divide into two parts, and you factor the first part and you factor the second part? I know you learned this in higher algebra. I'll get you started on it. You factor out 7x squared, and then what would you have left? Just the first part here. Don't even look at these guys yet. X and a 2, and is it a -2? Is that right? How can I know if that's right? Multiply this out first. Let's see if that works. Does that make what we started with? Yeah, it does, so it worked. Okay, so now we should do this other part. That's a lot easier. What comes out of those guys? 2. And what do you have left? Do you remember how that and that overlap, and now I can pull them out? I can factor them out. So those two factor out to the front. And then when they come out to the front, what's left behind? And this disappear. 7x squared plus 2. Now those weren't really disappearing for any math teachers that are watching. We'll just tell you again what really happened there is you divided by x minus 2. Divided by x minus 2. That canceled that. That canceled that. That's why the answer is this, and it goes in here. And there you go. It's factored. Does that ring a bell? Remember this? Okay. So there's another topic that may have been a little rusty. If you were asked to solve this, don't forget that on the final, calculators are allowed on the whole final. So I wouldn't waste a lot of time trying to do quadratic formula, or if it doesn't, I would try to factor, because factoring was way faster than the calculator, but this one doesn't factor. And I already told you just not waste time on the quadratic formula, because you could do what? Graph it. Graphing is the superior way to go. So grab a graph calculator, graph that puppy, and let's make sure that you can find the two roots. The two answers, the two solutions, the two zeros. There's lots of names for it, but we want the answers, which are the x-intercepts. So graph that puppy. You're going to find it looks kind of like this, but you'll need that little thing called second calculate the zeros to figure out what they actually are. write them down on your paper. I will pause while you do that part. All right, so I think, did you get 0.6 for that one? I think that's correct. Or is it 0.06 or what? It's negative. I know it's negative, but what? Some small decimal? Oh, okay. I could be wrong. I was trying to remember from last hour. Negative point what? 2426. Okay. All right. I'll take your word for it. I must have memorized it wrong. Can anybody verify that? Okay, good. Then the other one, I thought it was like 8 or something. Okay. Positive 8.24. All right. So I have found my roots. If my life depended on these answers, I would go and check them by plugging them in and seeing if they really make this equation equal what over here? 0. The whole point of these things is they always make this equal 0. That's why they're called the zeros. They're the things that would stick into the equation to make it equal 0. So if I put in an 8.24 and I squared it, and then I put in a 8.24 here, and I multiplied it by 8, and then I subtracted 4. And I had one kid on the test do that, and it came out to something that was close to 0, but not 0, and he thought that meant it didn't work. If it's really close, why would it be off? Because you're rounding. Yeah, it's not going to be perfect if you round the numbers. Okay, so it's only off a tiny bit. That's because of your rounding. It's still working. All right. How about this? I'm going to solve absolute value equations. Do you remember that these split into 2 parts? Once you got it down to just an absolute value, then you split it like this. X minus 2 is greater than or equal to 3. It's exactly the way you see it. Then the other side is x minus 2 is, I got to change this to a negative 3. And then, because I changed it to a negative, do you know what happens to the sign? Flips. And if you solve those 2 little equations, you'll have your answer. All right. That device needs to go on my desk. I'm not that good. I just happened to notice. All right, so now I'm moving to the next topics, which are from day 2, right here. And it's right there. Functions is f of x and g of x. Do you remember doing like f of g of x and f of 2 and g of f of 2 and that kind of stuff? We need to practice that a little bit. So what would g minus f of x mean? It means I take the one function, I subtract the other function. The g function, it's this one, minus this one. So if I go x squared minus 2x minus 1, what did I just do wrong? I just subtracted the functions. What could I have done wrong? I needed a parenthesis right there. If you subtract the one function from the other, this one subtract this one, I can't just put a minus capriciously only on the negative 2. I got to subtract both parts. So I subtract that and I put the negative on that. So this should have been x squared minus 2x plus 1. That's all it takes in math. Math is really particular. It's really, I've said this to you before, math rewards careful people. You can't just like not have a negative in the problem. It'll totally change the answer. If you're not really careful, it'll totally change the equation. There's, okay, I'll just stop there. So now if I was going to do g of f of 2, then I replace the x with a 2. So I just go down here and put a 2 in, and put a 2 in. So that'd be 2 squared is 4. 4 minus 4 would be 0. 0 plus 1 would be 1. So the answer would be 1 if I did that. All right, so using these 2 functions, I'd like you to see if you remember how to put one function inside of another function. And I'd like you to figure out for me what, let's get rid of this one, what would f of g of x be? Put the one function in the other function. So if the g of x function is like a cat being swallowed by the f of x function, which is a alligator, then the little cat is going to go inside the big scary, alligators are green, alligator. So I'm going to put this one inside of that one. So I'm going to make the alligator extra big. I'm going to put my black cat inside of it. And there we go. That's f of g of x. You put the g into the f function. All right. You know when they open up alligators after they've killed one, either because they're trapping it because it was a dangerous one, or because they just are out like fishing for them, so to speak. They're allowed to take a certain number of alligators per year. If you've ever seen Swamp People, it's got a what it's like for them to catch these alligators, and then they bring them back and they skin them and they get paid for them, and then the people make shoes out of them or whatever. They actually eat alligator meat down south too. So, you know, they found like all kinds of crazy things inside of alligators. They found license plates. They found just any like random chunk of metal you can ever imagine. They just eat like anything, and they're like garbage cans with fins. So anyway, they also sometimes have to try to catch local alligators to find out where the body went. Like if some person has disappeared, they check inside alligators, and they oftentimes will find that the alligator has like got parts inside them, parts. So yeah, you can find all kinds of things inside the alligator. All right, so now would you please figure out for me, if that's f of g of x, what's f of g of 7? F of g of 7. So then that's 2 times 7 squared minus 1. So that's 2 times 49 minus 1. And then that's 98 minus 1. So it'd be 97. Raise your hand if you had 97. Okay, good. So that's the idea of f of g of x. Do you remember inverses? Your final remembers inverses. Hopefully you will. Inverse is a 3-step process. The first step is you change that to a y. Okay? What's the second step? Switch them. What's the last step? Seems like you guys have forgotten this. It's a good reason to review it. Would you write that down, please? Just the last step I wrote. X equals square root of y minus 3. And solve it for y. Get the y alone. Once the y is alone, you'll have your answer. Okay, so hopefully you squared both sides. And I hope you remember that squaring both sides does not cause us to bring in absolute values. That's square rooting both sides. That brings in absolute values. But when I square both sides, I get x squared here, and the square root and the square root take each other off. That's why we did them. And I get y minus 3. And then I add 3 to both sides. X squared plus 3 equals y. Did I solve for y? Yes, I did. What do I have now? What did I just make? A kaleidoscope? What did I make? It's a what? Inverse. All right. So I have 2 inverses. I have that and that as inverses. Now square root and squared kind of are inverse of each other, right? And plus 3 and minus 3, those are inverse of each other. So it sort of makes sense if you think about it. Other things to remind you about inverses. If I have one graph and another graph and they are inverses, they are a reflection across this line. That didn't work so nice. I'm going to have to move it. Come on. Okay, across the line y equals x. Do you remember there's that function? That's called the exponential function. And there's this function. And that's called the log function because it looks like a log that's blown over in the windstorm. Off a little bit, but anyway, those are a reflection of each other because they are inverses. The natural log, this one's the natural log. You'll talk a lot more about that in second semester. That's the log, and that's the exponential function. Y equals e to the x, and this guy was y equals ln of x. You'll learn a lot more about those later, but those are inverses. They are a reflection over that line. Okay, and the last thing about inverses is that you got to remember this. Please write this down. It'll be worth knowing. F of g of x equals g of f of x, which equals x. That is the way you prove two things are inverses of each other. Write it with a pencil on the paper. Okay, now, if we're going to prove those two things that we just had were inverses, I need to call one of them f of x. So say f of x is the square root of x minus 3. Then g of x is the one we just figured out. What was it? X squared plus 3? Is that right? I think it was. Then, if these really are inverses, we should be able to do this thing where we set up f of g of x and we put it on this side of the line, and g of f of x and we put it on that side of the line. Wait a minute, oops, I only have one line. And then they both should come out to x at the bottom. Like they both should both sides should be x. I'd like you to take a second, put the g function inside the f function, put the cat inside the alligator. Do it on both sides. This is an easy one. You can handle this. And prove to yourself that this thing really will simplify down to x on both sides. So I'm putting the g function here into the f function here. Got to put this into this, so I put it right into where the x is. So I'll have square root of empty spot minus 3, and I drop in x squared plus 3. The cat goes in here. By the way, I like cats. Not trying to advocate that cats should be swallowed by other things. There are people who really don't like cats and there's actually websites dedicated to that. Alright, then this plus 3 and this minus 3 can cancel each other out. And so then it's just square root of x squared, which is, technically it's the absolute value of x. And the way I'm getting around that is by saying that if you used a negative x, do you get how if I used a negative x in there, I'd have an irrational answer? Because a negative underneath the square root wouldn't be allowed. So that's why I think it's okay to just have it be called plain x. On the other side, when you put the f into the g function, that would be proverbially putting the alligator into the cat, which is much more difficult. Put that over in here. I have empty spot squared plus 3, and I drop in a square root of x minus 3. And I'm the squared and the square root cancel each other out. It's just x minus 3 plus 3. And that, of course, equals x. So it worked. Kind of expected that it would be inverses because I made them to be inverses. All right. So now you've learned how to make inverses, how to check if they are inverses. You've learned on graphs of inverses that there are a reflection across the line y equals x. That's a few more things you'll be ready for when the test comes. All right. Do you remember the mixture formula? Amount 1, percent 1. It got you all ready for that on the test, and then it wasn't on there. Well, it was kind of a cruel trick, but I can't always just tell you exactly what's on the test. The final should include mixture problems, however, so it should be useful there. So if you didn't need it for this last test, hopefully you still remember it. I don't want to go over it again. We've done it many times in the last few weeks. Projectile motion. If you were to throw a ball up into the air, it makes a parabola. Looks like this. And that's the graph of it anyway. And this is time. And this is the height. Notice that this spot right here is really important. It's called the 0. Notice that there'd be another spot over here. Why wouldn't that ever be the answer on a projectile motion question? Because it's negative time. Can't have negative time. All right, so this is an extraneous answer, and this one would be a real answer. Okay? And if they give you a graph or an equation, you put it into your graphing calculator, and you're asked to find the highest the ball ever went, what's that code, what's word that you'd use for that? Looking for the maximum then. Yep. You find the maximum on your calculator. All right. I want to actually do one of these. So on your graphing calculator, would you please type in this equation? Y equals negative 16x squared plus 3x plus 4. Type that in. Graph it. Find me the highest that the ball ever went. By the way, the ball is thrown very weakly, so it's going to kind of drop off really quick. So it won't, go up very high like my picture. You know why I can tell it's been thrown very weakly? Because I know this right here is the velocity that it was thrown at. And it's very small. That right there is the y-intercept because it's where x equals 0. Both these parts would cancel. The y-intercept is 4, which means that when you started, the ball was already 4 feet off the ground. So it starts like this, goes up only a little bit, and then it starts coming back down again. Okay? So what's the highest the ball ever went? It should be something comma something. The x of it is how much time it took to get there. Mr. K, do you have that? What was the x of it? Good. So that means less, or only 9/10ths, no, 9/100ths of a second after it was launched, it made its top. And it was at how many feet? So it only went up 0.1 of a foot. So basically it just got barely tossed at all. And then it goes down and hits the ground right here. Would you please find that spot, everybody? That's called the 0. Make sure you're good at that on your calculator. Second, calculate the 0. If you're not typing in a calculator, you're not doing the right thing here. All right, Mr. O, what'd you get? There are two things, something comma something. What are they? And y is? And that makes sense, right? Because it hit the ground right there. Or hit the water if it was being thrown into water or whatever. So its height is 0. What is this then? Is this how far the ball went? No, that's a really common mistake for kids to make. That is a time. Remember, it's time versus distance. Time, or this could be height or distance off the ground. And its time is 0.6. That means half of a second about after it was launched, it hit the ground. Okay? All right. What if it was going in the opposite direction? What if it was going down like this? Same stuff would apply. Okay? This is, let's say, they have, not missiles, what's the things that submarines launch to hit ships? Torpedoes. They have those on ships. And they might start, see how it's starting off of above the water surface? Because the torpedoes are on the ship. And they launch them, they go off the ship and drop into the water, and then they take off heading towards their target underwater. Okay? So here's the torpedo's lowest depth it went, and then it comes up here presumably to hit the ship. So that would be just another way to do this problem where it's not a ball going in the air, it's a torpedo going under the water and the lowest it went kind of thing. Doesn't work quite as well because then projectile motion is a perfect parabola where this thing is being powered by something, and then the equations are totally different because it's got a motor on it. My brother was on a submarine, and their worst nightmare, of course, was either engine failure, because then the submarine just sinks to the bottom and is stuck there. And you only have so long you can last without surfacing. Second nightmare is depth charges. if something can drop a depth charge on you, it can basically crack the hull of your submarine and all the water comes in and everybody dies. And so there were some kind of crazy things that happened when he was on the submarine. It was in the middle of the Cold War with the Soviets, and not many people know this, but did you know that when the Cuban Missile Crisis happened, that down in Florida, there's a whole bunch of sandbars where it's dug out really deep right next to the sandbar. You know what that was for? For the submarines to hide right there next to the sandbar so they couldn't be detected. And they were sitting there with their nuclear weapons just in case. The Russians were trying to sneak nuclear weapons into Cuba so that they could have them so close to us that we could never stop them. You know what I mean? It's only like 100 miles away, which is like really short, quick hop to get nukes into the United States. So that's what the whole Cuban Missile Crisis was about. And what our response was, one of them was, we'll hide a couple submarines down in Florida ready to launch nukes from Florida if they attack us from Cuba. There was also subs cruising way up north in the Arctic, as in underneath like 7 feet of ice. There's so much ice on the ocean at some points that there's no way that the submarine could possibly break up through it. So they'd be traveling for like a month, and he said you could just feel the water was so cold that everything was cold. The submarine itself, you know, the outside of it was really cold because it was in super cold water underneath the ice. So you can imagine the feeling of claustrophobia if you're inside this big giant metal tube for like weeks, months at a time, and then the giant metal tube is under the water, which is then under the ice. So there was no way you were going to be able to come up. They have air scrubbers that can last a long time, and he was on a nuclear sub, so it had unlimited power source, so it could keep going for as long as he needed to. It had unlimited power, didn't have to go get back and get gas, you know, because it used nuclear. So anyway, just thought I'd tell you some of my brother's submarine stories, since submarines are another example you can use for quadratic. All right, and then there'll be probably one of these, maybe even 2 or 3 of these on the test. Do you remember how to do linear and quadratic regression? We've studied that so many times. Last thing I'm going to remind you is, if you're about to do it and you type this in right after it says quad reg, and you type in L1, L2, Y1, don't forget that typing in L1, L2, Y1 gets the equation into your Y equals button. So then when you hit your Y equals button, your equation's already there. I'd like you to try that right now with whatever data you have. I don't even care what it is. Hit stat. Make sure there's some data on your lists, as long as there's any numbers there. If there isn't, just put in some fake numbers. Then type linreg, only because sometimes quadratic reg doesn't like it if the data isn't quadratic. Type in linreg L1, L2, Y1. If you don't know where any of the buttons are, you got to ask me now, because I can't tell you on the final. The Y1 is under vars, V-A-R-S. Vars stands for variables. You see where vars is? And then underneath that, you go to Y vars, and then it's a function, and then you'll find it. Then, everybody make sure you can find the table. Go to second graph, and it's above that is the table. Quadreg is right in with linreg, and all the others, it's under stat. Calculate, there you go. Either do a linreg, if you want to do quadreg, it doesn't really matter to me. My main point is that you need to know where all those buttons are, and make sure you can get to your chart. Okay? So I want that to be a slam dunk easy question for you. So there'll be some on there that'll be like, oh, this is no problem. And there'll be others that'll be, man, we haven't talked about that in forever. All right, well, we got a couple more days of review. You got about 15, 20 minutes left here in class, so I want you to use it. I want you to be working on your yellow packet. I will give the tests back to you in the last, 5, 10 minutes. Is there anybody in here who has not taken the test yet? You were absent. There's usually at least one person. Nobody? So everybody took the test yesterday. Sweet. Then I can, yes, I can hand them back right now. save.